Did you know that Antarctica is 5.275 million square miles? Let's talk about polar area. Okay, how do we compute the area of the sector of a circle? Well, glad you asked. Let's say that this is an angle theta, and we're going to use radians, we're not going to use degrees. And so given that this is theta, if I wanted to know the area of the whole circle, switch colors again, multicolored, I would say, well, it's pi r squared, and that's great. I don't want the whole circle though, I just want this many degrees of it. Well, that many degrees out of how many degrees? Well, out of 2 pi radians, rather. And so then, for obvious reasons, my pi's would cancel, and I would be left with theta over 2 times r squared. And we can rearrange this a little bit, and we're going to rearrange it because in just a second, this is going to turn into this. So what I'm going to do is rearrange this to be r squared with a theta over here. You can do that, and you'll have a 1/2. Now, here's the deal. The area of a sector of a circle is this formula if you're in radians, right? And so since I want to know the area of a polar coordinate, I'll simply do this. All the components of this are right here. There's your 1/2, there's your radius function squared, and then d theta is theta. So when you were finding the area of something in rectangular form, you had some little function, you would do the integral of whatever your function is, f of x, and you did f of x dx, and it made sense because it's a rectangle. Like this would be a rectangle, and then another rectangle, and then another rectangle, and technically you have an infinite number of infinitely skinny rectangles, and so this is the width of the rectangle, and this is the height. And the formula for the area of a rectangle is width times height, base times height, however you want to call it. And so this is a rectangle. It's just the sum of a lot of rectangles. This is the sector of a circle. It's just the sum of radius squared, d theta, the little itty-bitty steps that we take with theta, just like we took itty-bitty steps here with all these little x increments, and then the 1/2 in the front. So I wanted to take a whole video just to explain this. Also, one more little thought. The function needs to be continuous, non-negative on the interval from alpha to beta. Alpha and beta are going to be angles. We often use Greek letters for angles, not always, but often. So there's alpha, beta, and theta. And one more random thought, just in case no one ever showed you. Alpha is the first letter of the Greek alphabet, and the second one is beta. There you go. You're welcome. That's where we get the word. So anyway, alpha and beta are the angles, and they are between 0 and 2 pi. So if I subtracted beta minus alpha, it would give me a number between 0 and 2 pi. So beta is going to be bigger than alpha.